Okay, hello everyone. We are pleased to host Leo and I are pleased to host the grade 6, 7, and 8 Math Kangaroo live solve. I see a lot of you have figured out how to use chat relay already, but in case if anyone doesn't know yet, to use chat relay, go to the chat function at the bottom of the Zoom meeting and send a direct message to chat relay, who should be labeled as a co-host. Then your name will appear here and your message, and so we can interact with everyone in real time. Anything to add, Leo?
No, it's a very, very succinct explanation, and hopefully we don't have to remind anyone. But yeah, messages go to chat relay, and then they appear down here, which is fantastic. Yeah, I think that's it. Should we get started with the icebreaker?
Oh, yes. Our icebreaker for today is, where are you from and what is one place you would like to go?
So if you had to choose from all of the places, just one.
Yes, in the whole wide world. Where are you from, and then what is one place you would like to go? Please put your answers through chat relay. This is like a bit of a test to see if everyone knows how to use chat relay. I see we have people from Massachusetts and California and Texas and New Jersey. Ooh, yes. Oh, these are some fast messages. Y'all are getting the hang of this really quick.
It's like when the teacher puts the first question of the exam is, what is your name? To see if you're paying attention. And it seems like you guys are paying attention.
Oh, yes. I see people want to go to Alaska and Tokyo and Japan and visit China. Yeah, these are all some great places to go. I've been to some of these places myself. And very great tourist destinations. Personally, I am from Maryland. And I would like to introduce Leo as well, who is from Seattle. Leo is a high school junior in Seattle, Washington State. He does AMC yearly, achieved DHR in 7th grade, and is qualified for Amy since 9th grade. He got second at his local UW Math Hour Olympiad twice. And he is also the captain of his school's Frisbee team and coaches the middle school team and his school's Quiz Bowl team as well. Oh, I see a fellow Marylander in the chat. Yes. And yeah, do you have any other people from Washington State, perhaps Seattle? Any of Leo's fellow countrymen? Another Maryland person.
Oh, I'm getting absolutely outscored. Okay, hopefully the Seattle people are still arriving. In the meantime, I'm going to introduce Joe from Maryland, who is floating on screen nearby me in some orientation. So Joe is a junior and has been doing competitive math since elementary school. He's qualified for Amy 3 times and enjoys competing in both math and physics Olympiads. He is also the tournament chair for his Mu Alpha Theta chapter and the captain of the school math team. And something fun I just realized is that Mu Alpha Theta is just math, because it's like the Greek letters.
That's true.
And I just realized. Anyway, warm welcome for Joe.
Yes. Thank you to everyone who is participating in chat. I'm seeing like a lot of these messages, and they're like scrolling up so fast that I can't even read them all. But let me tell you, I see them. And I would like to introduce someone else. Someone very special, our Math Kangaroo representative, Mr. Ravi Karan Karanjakar. He is a California State Director and an engineering manager at Amazon who exemplifies the perfect blend of professional excellence and community dedication. As the California State Director for Math Kangaroo, he has been instrumental in fostering mathematical thinking among young minds through innovative, gamified teaching approaches, much like live. Beyond his corporate role, Mr. Karanjakar's passion for education extends to running a nonprofit school that helps students maintain strong connections with their cultural heritage and mother tongue. His unique teaching methodology, which progressively builds from fundamental concepts to advanced problem solving, has inspired countless students in their STEM journey. Mr. Karanjakar is currently expanding the Math Kangaroo competition program while continuing his role as an official faculty member. So everyone give it up for Mr. Karanjakar, and I think he would like to give some words to the rest of you.
Hey, hi everyone. I hope you guys hear me well. And You might be able to guess from my voice that I'm still recovering my flu. But guess what? Mathematics and encouraging young minds is passion for me, and that's made me come on this call even though I'm sick. So I really appreciate. I see around 77 participants in this call, which is great. I really appreciate you coming on the weekend and taking this session. Joe and Leo would be taking you all through. Though this is a grade 6, 7, and 8 session, but usually in Math Kangaroo, we have grade 5 and 6 together and 7 and 8 together. So basically, it's grade 5, 6, 7, and 8. So this is vast chunk of our students who usually take exam or competition every year. And to give you some brief overview about what Math Kangaroo does, though this is being done in US right now, but we are in 110 plus countries. And every year, more than 6 million students participate in this competition, ranging from kindergartner until grade 12. And I'm sure each one of you who is in this call is participating or getting ready for the exam in coming 2 to 3 weeks. So I wish you all the best for all of you who are participating and going into competition. This year we are planning to do awards for the top 10, but we'll be giving the top 20 ranks onto the website because the students have been increasing year by year. So this year we have more than 60,000 students registered for the competition in US. And another interesting thing for some of you to know is this year, actually we did it in 2025, but we have started with the team competition as well, where friends can come together, form a team, and do the exam as a team. It's like a team effort. Out of whatever questions, you can divide and conquer and get all the questions right in a very stipulated time. And another differentiator for this uh, team competition is unlike regular competition where you have every question with multiple choice options. Team competition, we deliberately defined some questions where you won't have any options, which will really test your mathematical skills. So those who have not participated in the team competition last year, which is just a new beginning, we did it on the pilot basis, and we want to keep on expanding starting next year. So registrations will open in June, and the exam will take place in November, and the individual competition always happens in March. So wish you all the best, all the students, and I look forward for Leo's and Joe's explanation for several questions today. And at the same time, I would like to give some practice material for students to practice at home because I know Joe and Leo would be able to cover very limited questions today. So I'm dropping some notes here. Maybe Joe and Leo, you can forward it to the rest of the team for the practice links. At the same time, we recently conducted a mock test. This is like a competition before a competition where several students participated in this mock test and they got to know how to participate in this exam, how to answer, what mistakes not to do, because there are so many people who are participating for this exam for the first time. So we have also written a blog for those newcomers to get used to. Uh, so Joe, I'm sending you the link. Please send it across the team so that they're familiar with some learnings which you have learned from the mock test. Because in many exam, you usually submit your question paper back to the proctor, your answer sheets back to the proctor, and you or your parents don't get to see what mistakes you did, and you realize, oh, how come I got this so less marks or so mediocre ranking? So this time we gave the question papers as well as answer sheets during the mock test to the students, and we asked them, "Hey, what are the learnings from this mock test?" And they wrote us several feedbacks. And this blog post is about talking about some of those learnings students and parents came back to us. So, if any of you is a first timer or still would like to know what mistakes can happen, please go through the blog post. Let me see if I can send it to all. I think I don't have an option, but maybe Joe, you can let students know at the end of the session. And with that, uh, I would like to let Leo and Joe go ahead. But before that, Leo, Joe, would you like to mention any hobbies you have other than doing math questions for the students?
Yeah, of course. Uh, for me, one of my biggest hobbies is ultimate frisbee, and I'd say my other largest hobby is Quizbowl. How about you, Joe?
Oh yeah, I love myself some good old strategy games, and I also play tennis. And so, yeah, thank you so much to Mr. Karanjakar for his kind words and his great explanations on Math Kangaroo. I mean, it's a big organization, so I strongly encourage everyone here to go ahead with those competitions. Speaking of those competitions, we have some certain problems for those competitions today to go on with. You think we should get started, Leo?
Yes, it's perfect timing. Let's go.
All right. Question
Okay,
one.
question one. On Monday, Alexandra emails a picture to five friends. For several days, everybody who receives the picture emails it the next day to two friends who haven't received the picture yet. On which day does the number of people who have received the picture become greater than 100?
Ooh. This is an interesting question. So, let's go day by day. Shall we, Leo?
Yeah, let's start on Monday. So, Monday, huh. I think Monday would just be five people because that's just who Alexandra sent it to. Is that right?
Yeah, that seems to be about right. So, let's write that down for Monday. Let's see. M N D A Y. Okay. And so, let's go to Tuesday next. How many people do you think would have it by Tuesday?
Well, I'm wondering if Alexandra is going to send it out again to two people because she's already received it. I was thinking no. I was thinking just these five people who just received it are going to send it out. Do you think that's the right interpretation here?
Yeah. It's on each day, everybody who receives the email emails it next day to two new friends. And so, if you've already received the email like way before, everyone who receives it only emails it the next day. And so, I think there shouldn't be any more duplications here.
Okay, that makes sense. So I think because we don't really want to keep track of all the people who have it, we just want to see the new people who receive it because that's what's going to make it easiest to calculate the next day. Maybe we should do like five and then plus 10 because 10 more people will receive it, and then those people are going to be the ones who are emailing. Does that make sense?
Yeah. Because each of the five friends who's received the photo the picture on Monday sends it to another two people, meaning that each of those five produce 10 more people. So let's see. The next day of the week, that one's Wednesday. So let's ask the chat this time, Leo. I think we've done enough talking. What do you think should be the number added for Wednesday? Put your answers in the chat. Monday we have 5 people. Tuesday we have 5 plus 10 people. Wednesday, well, we still have the people of 5 plus 10, but how many other people should be added? How do I spell Wednesday? Wednesday, yes.
I, I'm seeing the chat explode with plus 20, and I think that's correct because it's just doubling, isn't it? Like 10, and then each of them is times 2, so 10 times 2 is 20. I think that makes sense.
Yeah.
Okay. 5 plus 10 plus 20.
Now, I think we've pretty much seen the trend here, which that when they send it to two friends, the amount of new people that are added should double. And so, I think the chat's done plenty of help with us with Wednesday. And so I think we should ask them again for Thursday. How many people should be added on Thursday? Yes. Oh, I'm seeing the chat. The chat is going wild. I see people are. Yes, I think we should add. Ooh, I'm writing off the screen. But 5 plus 10 plus 20 plus 40 is the total number of people that we'll have by Thursday. Now, how do we use this information to solve the problem again, Leo? Can you bring us back on track?
Oh yeah. So we want to figure out which day does the number of people who've seen the image become greater than 100. So it's not by Thursday because on Monday, Tuesday, Wednesday, Thursday, we've got 5 plus 10 plus 20 plus 40, which does not exceed 100. And on Friday, we're going to get 80 more people because it's double. So answer can't be Friday, can it?
Well, I mean, it depends on the definition of the problem. Is it the number of people who have received the picture on that day, or the number of people who have received the picture in total? Which one do you think it should be, Leo?
Oh, actually, I think it should be the people who have total received it, which would mean that it's not about the day's additional people being more than 100. We just need the total sum to be more than 100. So it would be 5 plus 10 plus 20 plus 40, not greater than 100. But then when we add on Friday, we do get enough so that the total sum is more than 100. So then I think the answer would be Friday.
Yeah, I think so too. And I see the chat. I think the chat agrees with us. They're putting C Friday. A lot of C's. A lot of people saying trust the process. And I think, I've done a few of these live solves before. And the one thing I've learned is that chat is almost always right. And so, do you think we should look at the answer, Leo?
Yeah, I'm confident in our answer. Let's see.
Let's go. And would you look at that? It's Friday. Another excellent performance by chat. I mean, that's like what? Like 30 for 30 on chat answers? Yes, huge W.
Oh, yeah.
Yeah. And with that huge W, I think we're ready to move on to the second question. What do you think, Leo?
Yeah, let's do it.
John does a calculation using 4 digits, represented in the addition by A, B, C, and D. The question is, which digit is represented by B? Ooh, this is an interesting one. Where do you think we should start off with this problem, Leo?
I don't know. Well, this is a puzzling one. I kind of want to just try things. Well, here's the thing. I guess this part, this C plus A, like these two columns, they look useful to me. And it's like not only does C plus A equal D, and then C plus A again gives us D, but it also gives us a carry. So that means C plus A is like more than 10, right?
Yeah.
More than 9.
Yeah. So we know that A plus C has to be a pretty big number. But let's think about D next. Given that we're adding 2 3-digit numbers and we get a 4-digit number, what's the only possible number for D? Given that, both ABC and CBA are less than or equal to 999, what is the only possible way that we can fill in this D? And I'm seeing in the chat, I see Yuri, Agrada, they're saying D must be equal to 1. Yeah. How did they reach that conclusion, Leo?
This is really sharp. So if we had, of course D is not 0, but let's say for a second it's not 1 either. If it were like 2 or something larger, that would mean that A plus B plus C, or that ABC plus CBA was greater than 2,000, and that would mean each ABC and CBA are both less than 1,000 because they're 3-digit numbers. So that means D can't be bigger than 1.
And since we also know that D can't be 0, or else like this would all be trivial, we know that D must be 1. So let's write that in. Yes. Thank you for everyone in the chat who put in 1. I see you. Plus 1 equals 1. I'll just put A, B, C, and C, B, A. Ooh. Oh, that's a clever use of the eraser to get rid of those D's. Much more efficient than mine. Yes. Where do you think we should go after this, Leo?
I think we should look at these columns that I highlighted initially because I think there's something fishy going on here. Well, uh, yeah, I think there's something fishy going on here, and maybe it can give us a hint about what B is.
Yeah. Let's see. What do you think we should do about these columns right here? I mean, we know that C and A have to add up to something with. Well, let's say that C and A. Let me write this over here. It's in pink. No one can see that. But C and A must add up to some number, and we know that that number has to have an ending digit of 1, like Leo's pointed out, which is mighty fishy here, because if we have A and C adds up to an ending digit of 1, that means that this one right here, since, let me delineate it here, this one also has an ending digit of 1, meaning that we can't have carried anything from the two B's. So there can't be any carrying nonsense going on here. Yeah, so that's an interesting way to go about it. Where do you think we should go next with this, Leo?
Actually, I realized we don't only have the last digit of this sum, we also have the second to last digit. So, because we get no carries, as Joe pointed out, and then we get this 1 up here, that means that A plus C is a carry. That is, it's bigger than 10. Or it's bigger than 9. So it's going to get this other digit over here. And we know it's like 11, 21, 31, 41, but we can immediately tell it's got to be 11 because kind of the same way we figured out the number of digits gives us this 1 right here, like all ones. The same way we can tell that two single-digit numbers, when added, do not exceed 20. So that means C plus A actually equals 11. And then I think that gives us a huge hint towards what B has to be. What do you think, Joe?
Oh yeah, I think that gives us a massive hint. After all, we have this equation right here. And so let's just add all the A's and C's before we add the B's. Well, this C and this A, let me pick a different color now. This C and this A make 11. And these A's and C's in the 100th place make 11 times 100. And would you look at that? That's the entire number, I think, Leo.
Interesting. So therefore, how much do these B's contribute?
Yeah. If we've already gotten the entire number from the A's and C's, then the B's must have contributed nothing. So, and that's especially interesting with this problem because it actually doesn't matter which values A and C are. In fact, you could have, for example, 307 and 8. Let me change the 7 to an 8 and 803. You could have 209 and 903. But any pair of A and C that add up to 11, well, the middle digit has to be 0 in any of these cases, which is pretty interesting, don't you think?
Yeah, I think that's a great result. I like problems where you can solve it without uncovering all of the numbers, where you can just get the solution kind of like an art thief. You kind of go in and grab the solution without getting everything else or being detected.
And I'm seeing a lot of zeros in the chat. I've actually been seeing them for a while. And so I just want to say, like, everyone, we see you? Yes. We read chat. We're just going through the entire process. So
Yep.
yes, great job to everyone in chat. Yes, and I think we're ready to look at the solution.
Yeah.
I think chat's been spamming zeros as well, so I feel pretty confident in this one.
All right.
And the moment of truth. Hey, it's zero. Another W for chat. Let's move on to the next question, where I'm sure chat will collect another W. Do you like to do the honors this time, Leo?
Uh-huh. I got you. The question is, five balls A, B, C, D, and E weigh 30, 40, or sorry, they weigh 30, 50, 50, 50, and 80 grams each, not necessarily in that order. Which ball weighs 30 grams? And then we've got some example balances right here.
Let's see. Now I've made the picture a little larger on my screen. I'm going to write out all the numbers first, because that's a good way to start with all these. So we have a 30 gram, a 50 gram, a 50 gram, an 80 gram, and another, oh, sorry, 350 grams. Yes. 50, 50, 50, 80.
And a reminder for people who were here last month, thank you for coming back. This is not the same problem, but we can use the same solution techniques, like looking at a balance scale and thinking to ourselves, which balls could possibly be on which sides? All right. Little reminder over. Let's start with the problem.
Yes. And so these unequal balance beams, the inequalities don't exactly give us all the information we need. So I think we should take what Leo just said and look at this balanced one. Yeah. And so we have A plus D is equal to B plus C plus E. Yeah. And how do you think we can use this information, Leo?
Okay, here's what I'm thinking. I think we can eliminate A and D immediately because here's my logic. Let's say A or D was the 30. So this left side would be like 30 plus something. That means even if the other ball were the heaviest, 30 plus 80, and we've got 110 grams, the other side would be at least 150. So that means they can't be balanced. And therefore, neither A nor D could be the 30-gram ball. So
Yeah.
I'm just gonna go over here and cross these out. I think we also have that A or D must be the 80-gram ball because if each of them were 50-gram balls, let's play that one out. So we've got 50 plus 50 equals 100. Oh. And the other side is 50 plus 30 plus 80. We would get 110. And that wouldn't work either. So, or wait, we get 160. Did I do that right?
I think we have 150 if we're adding all of the 50 balls up. And with the
I
80,
mean, if we had only 50s on this left side, if A and D are both 50, then we get this problem where we get 50 plus 50 equals 30 plus 50 plus 80, which can't work. So therefore, we also have to have A or D is the 80-gram ball. That's what I'm saying.
oh, yes, yes. I think I picked it up. Yes. One of A or D is the 80-gram ball. Since we have 80 plus 50 is equal to 30 plus 50 plus 50. And since we need these two to equal, we also know that one of them is the 80 ball and one of them has to be a 50, which is one of them is 80 and one of them is a 50. So, where do you think we ought to go after this, Leo?
Well, I think we've gotten about as much information as we can out of this first balance, but we have two more balances to look at. How about what what if what if we looked at the middle balance? Maybe that'll be useful.
Yeah. We know that E and B added together are heavier than A and C added together, which is interesting because there's two balls on each side, and we know that A is either the 50 ball or the 80 ball, but is lighter than E plus B. So, what do you think this tells us some pretty important information, specifically about ball C? Yeah. What does everyone think ball C should weigh? Given that A is either 80 or 50, and A plus C is lighter than E plus B. Yeah. Oh, I'm seeing a lot of answers in the chat. I'm seeing Kelly and Manjari. They're saying that C is 30. Oh, I'm seeing loads of other people saying C is 30 as well. Yeah. How did they get that? Can you help me with this, Leo?
I think they're doing kind of a worst case scenario, or maybe best case scenario if you want to solve the problem. So, of these balls on the left side, E and B, we've got two that weigh either 30 or 50 grams. But let's play it out. And let's say either E or B would be the 30. So that would mean we have 30 plus 50. And there are no two balls that can be lighter than 30 plus 50, especially if the 30 is already taken. This is just not going to work. So this needs to be 50 and 50. And that also leaves C as the only remaining option for the 30. Does that make sense? Do you think that's reasonable?
Yeah, I think that checks out. And so now we have that the A or D is 80 or 50, and we have the C is 30. And so, hold on a minute. I think that's just the problem.
Yeah, I think that's all we need to find out. So, I guess we just stop here and call it a win, right?
Oh yeah. I was fully prepared to keep trying to find the other weights. But see, that's why it's important to read the question carefully. Yes. Yes, you must in these types of competitions. And thank you so much to everyone in the chat for helping us solve this problem. And yeah, I feel pretty confident in the chat. How do you feel about it, Leo?
Very confident. Let's take a look.
Ooh, hold on. I think I
Again, okay, it says C. So that means we got it correct again. All right.
Incredible.
Should we move on?
Yes, let's move on.
Okay. Got a large word problem. Let's see. I'll read this one out. Okay. The sum of the ages of Kate and her mother is 36, and the sum of the ages of her mother and her granny is 81. How old was her granny when Kate was born? This is not a lot of information to go on.
Oh yeah. This sounds like a classic word problem. And for these algebra word problems, I think the first step is to set things into variables so we can do math on all of the words, convert them into numbers. So let's say the age of Kate is K, the age of her mother is M, and the age of her granny is G. How do you suppose we should use these variables to construct equations, Leo?
Well, I think they just gave us two statements, and we can convert those two statements into two equations. So the first one is the sum of the ages of Kate and her mother is 36. So how can we use that one?
Yeah. Put your ideas in the chat. What equation can we use using K, M, and G to use this piece of information? What equation does this become? Ooh. Oh, I'm seeing Anthony saying x plus, ooh, you're using slightly different variables, but I see the idea, yes. I'll keep using the K and M, but x and y also work. what I saw Anthony say is that k plus m, or I don't know where that other line is coming from, k plus m equals to 36. And then we can use the same piece of logic again, that m plus g is equal to 81. But wait a minute. I remember learning in algebra that you can only solve for each value of a system of equations if you have the same number of variables as equations. And we have 3 variables here, but only 2 equations. How do you think we should solve this, Leo?
Yeah, it does seem impossible, but hold on. We're not exactly looking for any of the variables. We're actually looking for a different value. We're looking for the value g minus k, right? It's how old is the granny when Kate was born. So Kate's age years ago, how old was the granny? So g minus k. And actually, we can use a tricky algebra move to figure out what this one is. And that's just by, I think, as people have been mentioning respectfully in the chat, just by subtracting these 2 equations. So that would be like m plus g equals 81, and then subtract k plus m equals 36. So, Joe, do you want to compute that one for us? What would that equal?
Yeah. Well, we'll have the m's cancel out here. So if we're subtracting this equation from this equation, we get g minus k is equal to 81 minus 36. And then the rest is just arithmetic. And I think I've seen the answer many, many times in chat. And I see people putting 45, and I think that seems about right. What do you think, Leo?
Sure, I trust the chat. I'm not going to pull out my calculator, but let's just go with the chat.
Yeah. And I have pretty high faith in this problem. Pretty high faith in the chat as well. Do you reckon we should look at the solution now?
Yeah, let's do it.
And voila! 45 it is. Yes, this granny is very tough. Yes, I agree. Yeah. But perhaps we'll find something tougher in the next problem.
Only time will tell. Okay, let's look.
Oh. What is the value of 20 plus 18 divided... Hold on. I think there might be
Maybe there's a typo here.
There's a typo in this problem, because if we simply have 38, which is 20 plus 18, over 2018, then this number is less than 1. And so I think there's been a typo somewhere on this problem. Now, this is the perfect time to introduce everyone to Rat Chile. Rat Chile is the evil cousin of Chat Relay. He scurries around, and then he ruins our audio, he ruins our videos, he ruins the typos. And I think Rat Chile has messed with this problem.
Hold on,
So-
Joe. Yes? Okay. I'm hearing from Math Kangaroo headquarters that there has been a typesetting issue, and the problem should have been divided by 20 minus 18.
Ah.
Okay.
Yeah,
So
that
my
makes much more
corrections. This is why we're here live. Okay. So what if we solved this problem instead?
Yes. This problem is not solvable with these answer choices. So let's look at this one instead. Well, this question is arithmetic. So I think we can just simply add the things on the top and subtract the things on the bottom. What do you think, Leo?
Yeah, it makes sense to me. So 20 plus 18 would be, as you mentioned earlier, 38. And 20 minus 18, well, that's going to be 2. So what's 38 divided by 2?
Yeah. Well, I see the chat. The chat has been yelling at us, yelling the answer at us the whole time. And I
Yeah.
think, yes, I'm seeing 19. I see someone put like four 19s in there, so I think they're four times as confident.
I'm very confident. And by the way, the whole competition isn't this easy. This is problem number one. So it's going to get more difficult from here if you're taking the seventh and eighth grade test.
Oh, yes. It
And
only
this is
gets harder.
2018. So because of inflation, it would be more difficult at this point also.
Yes. Problem inflation is a real problem affecting our citizens. Yes. But the answer, I think, I've sped a little ahead, but I think the chat has gotten it correct. It is B19. I think we can move on to another tough problem.
All right.
Ooh, this is a lot of pictures. The panels of Fergus's fence are full of holes. Oh no. One morning, one of the panels fell flat on the floor. Which of the following could Fergus see as he approaches his fence? Let's see. So, this is the correct fence. We're trying to see what would Fergus see if he was looking at it from perhaps a different angle. How do you think we should start with this problem, Leo?
Well, one of my favorite things about Math Kangaroo is these visual problems. And I think the best way to do these visual problems is to rule out all the answer choices except for the correct one. Because you want to make sure you didn't miss anything, so you want to rule out everything else. Just because something looks right. Like, these all look the same if you just glance at them, right? But you got to make sure that you have the only correct answer because these are so deceptively similar. Okay, and my suggestion is we start by looking at these circles right here. And looks like all the circles are the same, but they're not because there are these circle-shaped holes near the top of the fence. And so if you look closely, you got like it's kind of hard to show, but you got like, I'm showing in yellow, there's two lines. There's like one up here and one over here that are like kind of holding the fence posts together. And these circles are closer to the top one than the bottom one. So if the fence falls over, we've got to make sure that these holes are closer to the top side. And what the top side would be is just closer to these jagged edges on top of the fence posts. So, Joe, do you want to go through each answer choice and see if any of these don't have that property?
Yeah. Well, A looks about right, but B, these circle holes are way too close to this bottom rung, and so I think we can safely eliminate that one. E also looks like it has the same problem, and so I think we can eliminate that one as well. I realize that it's difficult to see my lime green over the white, so I'm going to scribble it out instead. Let's see. Well, we've already looked at the circles, so I think we should try looking at the triangles next. What do you think, Leo?
Yeah, good idea. So I'm seeing five triangles everywhere. What do you notice about the triangles, though, that you think could be potentially helpful to rule out some of these options?
Yeah. All these triangles up here look like they're equilateral triangles. Equilateral triangles with three of the same side and 60 degrees in here. And if we look very closely at the triangles in A, these do not look equilateral. No. So I think we can eliminate that one as well. And that just leaves C and D. Now, these look pretty similar to me. What is the difference between these two, Leo?
As I'm seeing in the chat, people noticed that some of them are pointing up and some of them are pointing down. So the crucial thing to check is, are there more pointing up or more pointing down? And when I say up, again, I mean towards the pointy part of the fence post. So when the fence is upright, we have three that are pointing up. And I'm going to show them in purple now. So these three are pointing up, and only two are pointing down. But when we look at answer choice D, we can see that there are still three pointing up, and there actually should be three pointing down, because whatever is up is now down. So that means we can rule out D. The correct thing is C, because there are 3 that are pointing down in C, and that's the correct number to be pointing down. Does that make sense? Is that right?
Yeah, since the 3 that are pointing up in this one, it's flipped. And so when you take something that's pointing up and flip it, it becomes pointing down. And so I think that this is correct, and I'm seeing a lot of C's in chat. And this is, if I've learned anything, chat is always right. Yes. So let's see. Let's see the answer. The moment of truth. It is C. Yes. Excellent job. Excellent job, everyone. Let's see. Let's move on to the next one. The problems get harder and harder. So if you've blitzed through, maybe perhaps these will be more of a challenge. Would you like to do the honors for this problem, Leo?
Yes, I got you. Okay. The diagram shows a rectangle with dimensions 11 by 7 containing 2 circles. Each circle touches 3 of the sides of the rectangle. What is the distance between the centers of the 2 circles? Huh.
Let's see. Well, I remember, if there's one thing I know about circles is that all of the points are the same distance from the center. And so I think it might be useful to use that tidbit of information. The radius is always the same. So let's see. There's a lot of radiuses I can draw here. There's one over here. There's one over here. There's one over here. But these 2 radiuses that I'm circling in green right now, these 2 radiuses are just the height of the rectangle, which means I think that gives us some really, really important information on what the value of the radius is. Yeah. Can you put in chat what the value of the radius should be? Given that these 2 radii, that's the proper way to say plural of radiuses. What should the radius be? Ooh, I see someone's put it in chat. Fei Yi, 3.5. How do you think they got that answer, Leo?
I think they got it from the whole height of this circle, which is the diameter, or 2 radii, would be 7. So you can get the radius by dividing 7 over 2. And personally, I hate decimals. Do you think we can leave this in a fraction as just 7 over 2? Hopefully that's okay.
I think the fractions, something nice will happen to them. So let's keep it in fraction form for now. So let's see. What are we looking to find? The distance between the centers of the circles. Well, in any geometry problem, it's probably helpful to draw out all the things we're trying to look for. So let me connect the centers of the circles. But wait. If we draw another radius over here, this makes another straight line. Ooh, yes, it's better drawn on Leo's screen. Leo, would you like to explain what you've drawn?
Yeah, so I've drawn from the left a radius that goes from here to the center. Then I've drawn a purple distance and another radius. So actually, this purple distance right here is precisely what we want because it's the distance between the 2 centers of the circles. And now the question is, how can we get that purple distance? And I think people are already mentioning this in chat. Joe, did you catch what they said?
Oh, yes. I see Agrada saying that if the radius is 3.5, then these 2 radiuses, or radii, should be 3.5 times 2, which is just 7. And that plus the... Ooh, there's balloons on my screen now. That's pretty cool. And that plus the distance between the centers of the circles should be equal to 11. Oh, wow. The balloons are really invading my screen today.
I believe if you do this on Zoom, it will show balloons on your screen if you have a certain setting enabled.
Ah, I see. I was about to think Rat Chile was messing with my setup again, but this time it was Zoom. Zoom and Rat Chile must be in cahoots. But yes. 7 plus distance between the centers of the circles, which means we can just subtract, I'll just call it d for distance. If we subtract 7 from both sides, that gives us the answer, which is 4. Now, I've again seeing all of these answers in chat, and I think the consensus is that it's D. Yeah. Do you believe in the chat, Leo?
Yes, I believe in the chat. Let's
All
look.
right. Let's take a look. Ooh, that's a diagram. And there it is. Victory is ours. Let's see if I can get the balloons again. Yes, these are celebratory balloons, not unintentional balloons. All right. So, that's another well-solved problem. Let's move on to the next one. Philip wants to know the weight of a book with 0.5 gram precision, so very precise. His weighing scales only weigh in 10 gram increments. What is the smallest number of identical copies of this book that Philip should weigh together to be able to do this? This is a lot of words, and it's not immediately obvious how to put this into equation. How do you think we should start off with this, Leo?
I guess we could. I'm not so familiar with this type of problem, but my instinct is to define a variable for the weight of the book. Maybe W could be the weight of the book.
Yes.
And
Yeah.
and I see the chat's kind of exploding on D, and I suspect this is because answer choice D times 0.5 equals 10, but we can't just jump to conclusions. I want to be sure of our answer, even though the numbers in the problem do like work together to make that answer. So
That's true. Well, let's see, what weight would we get if we put a bunch of books on the scale? Well, the weight would just, I'll say we have n copies of the books. It would be n times W, and which is the weight, which would be the weight on the top. But we only have 10 gram increments, which is not a lot. So there's a bit of uncertainty in the number that's measured. So let's say our measured number is m for measured. We know that n times w must be somewhat close to n times w. It has to be less than 10 grams off. Less than is this 10 gram increments? Does it round or does it just go up one at a time?
I guess it's like giving you a weight that's a multiple of 10.
Yeah. So the m has to be between the, let's see. No, sorry. N times W has to be only 10 off of m, which means that it must be between less than 10 off of m. So it must be between m plus 10 and m minus 10. Or does it go by m plus 5 with the 10 gram? I'm just going to assume that it is n plus 10 and n minus 10. Let's see. Where do you think we should continue after this, Leo?
Well, I think this could be kind of expressed like you could say the uncertainty is 10 and then I don't know. I want to see some bright ideas from chat.
Yeah. We have this inequality here, and we're trying to find the weight of a single book. So, how can we rewrite this inequality so we just have a W alone here, which would be the weight of the book? Yes. Yes, please put your answers and ideas into the chat. Well, I'm seeing a lot of people putting the final answer to that, and someone is putting an entire explanation. So let's see. Let's go on with the next step of this. So we want to find the weight, but just the weight. We don't want this n here. So if we divide all of the parts of this inequality by n, we get m minus 10 over n is less than or equal to w is less than or equal to m plus 10 over n. So we want this uncertainty to be 0.5 grams at most. And the uncertainty here is I see I'm writing off of the screen again. Oopsies. Yeah, so would you like to continue with the explanation, Leo, while I keep writing everything on the screen?
Yeah, I think the smart trick Joe's done here is that by weighing more books and then kind of dividing m, which is the measurement that the scale gives us, we can divide by n, and that also divides the uncertainty. It makes us more certain about the book, so we can get better precision on the book's weight with our less good scale. So I think he was about to say the uncertainty would be 10 divided by n, whatever n is, and we want this to be less than 0.5, or less than or equal to 0.5. So the question is, what is the smallest number of books we need for this to be the case?
Yes. Well, less than or equal to 0.5. So we just solve this equation, and after moving the 0.5 over here and the n over here, we have n is greater than or equal to 10 over 0.5, which is equal to 20. And I've seen a lot of people putting D in the chat, because this seems about right, because the chat has been saying it the entire time, and the uncertainty is just dependent on the fact that the scale only comes in these increments, for those of you asking about that in the chat. So I think that it should be answer choice D. What do you think, Leo?
Yeah, I think it's answer choice D. And, well, let's look.
And
All
would
right.
you look at that? Chat has gotten it again. Once again, chat reigns supreme. It is D, as many people have been saying thus far. And yes. We only have 2 minutes left. Do you think we have time for a really fast problem, Leo?
Yes, there's always time for a really fast problem.
Let's speedrun this next one.
Okay.
A hotel on an island in the Caribbean advertises by using the slogan 350 days of sun every year. According to this ad, what is the smallest number of days Willie Byrne has to stay in the hotel in 2018 to be certain of having 2 consecutive days of sun? Now, it says to be certain. So this is like 100% chance. And we have to consider the worst case scenario for this. What do you think the worst case scenario would be, Leo?
Well, if Willie Byrne is going to be spending as much time in the worst case scenario, if we say it's bad to spend more time on the Caribbean island, then the worst case scenario would be he starts with a day of sun, and then there's no sun, and then he gets hope again because the next day is sunny, and then, of course, it doesn't happen, and then the next day there's sun, and then the next day there isn't. So just alternating like that, and starting with a day of sun. So we only actually have 300,
Yes.
365 or 366. Okay, 2018 is not a leap year because leap years must be multiples of 4. And 2018 ends with 18. So it's not going to be 366 days. It's 365 days. So that means there's 15 days without sun. Okay, and then Joe, you were writing SN, SN. Do you want to
Oh,
continue?
yes. This is the S represents sun, the N represents no sun. And we're ordering like this because this is the most inefficient way to organize them. If we just had a long run of no sun, then, well, I mean, we would run out of our 15 days of no sun real quick. Just like we're going to finish this problem real quick. But we can insert basically 3 days of sun in here that still won't satisfy Willie Burns' condition, but will artificially inflate the amount of time. And so we have SN, SN, N, dot, until the last N is used. And then finally, we're forced to add 2 more S's. And so we just want to find the number of days in this whole thing. How do you think we should go about that, Leo?
I think we should count the S's and the N's. So we've got, of course, 15 N's. 15 N's. And the question is, how many S's? So before every N, there is an S. So that's 15. And there are 2 at the end. The ones that, the 2 days in a row that Willie Byrne actually gets consecutive sun. Because we're looking for the smallest number that it will actually happen. So I got 17 S's. And now we need to add these together.
Yes. And so we just get 15 plus 15 plus 2 gives 32, which is an answer choice. And wow, I'm seeing a lot of D's in chat. So I think I feel pretty good about this answer. What do you think, Leo?
Yeah, and that was a really speedy solution. So let's look.
And would you look at that? Chat is proven right once again. We are assuming that the ad is not false advertising and that they would get sued in that case. But it is 8:33, and I think that concludes our Math Kangaroo live solve. Thank you to everyone who came here. We really appreciated everyone who sent their ideas in chat. You are the lifeblood of this stream. Couldn't have done it without chat. Any closing words, Leo?
Get outside and see the sun.
That's true. See the sun. Enjoy the Caribbean islands. Yeah. I remember from the beginning that most of you do not live in the Caribbean. So unfortunately, I think you will only be able to do the first part of seeing the sun. But yes, thank you everyone. And everyone have an excellent evening. Have an amazing evening. Have the best evening. And yes, goodbye. Thank you. And I will see you next time.
Goodbye, everyone.
Bye, everyone. Thanks for coming.